Hello, and welcome to the 4911 CyberKnights training. Today we're going to do session 5, which is going to involve program logic and indefinite loops. But first to review, last time in session 4, we did some loop techniques, including cumulative sum, where we added up a bunch of numbers, and then we talked about the fence post problem, where we're trying to do something either before a loop or after a loop. We had to account for an extra step. And then we talked about if-else statements and how to use relational operators and how to improve our cumulative sum solution with an if statement and how to improve the fence post solution with an if statement. And then we also talked about nested if-else, where we have multiple tests and multiple controlled statement blocks that we want to add to our logic. And then there were some subtleties that we went over for conditional execution, like object equality and how that differs from value equality, round off errors, how you can kind of get tripped up with decimal values in Java in surprising ways, and how to clean up our if-else statements. We also showed an example of how to find the minimum or the maximum in a set of numbers. And then we talked about some methods with conditional execution, both preconditions, which are things that you expect to happen before a method is called, and postconditions, which are things that you expect to have happened at the time that your method completes. We talked about throwing exceptions in order to protect and enforce our preconditions. And then we talked about return values again. And then we did a hands-on example with body mass index. Today, we have a shorter list. We're going to talk about the while loop, which is just different syntax. It's actually a different structure entirely than the for loop, how it's useful and how it's similar. The boolean type, which we've been using for a while, but we're just going to clear some things up and go a little deeper in that. And then indefinite loop variations. We'll explain what that means when we get to it, and then we'll wrap up with an example. Okay, cool. So let's start right off with the while loop. The thing about the while loop is that it's actually simpler than the for loop. Instead of having a three-part structure where we have the initialization, the test, and then the update step, a while loop just has one thing inside the parentheses, and that's just the test. And the test controls whether the loop continues going. In fact, let's just look at the flow for that. Here's the flow for loop, where we do init once, initialization once, we check the test. If it's true, then we execute the controlled statements or the block of the for loop, and then we perform the update afterwards, and then we go back to the test. And if at any time the test is false, then we just resume execution at the end of the for loop. The difference with the while loop is pretty stark. You encounter the test right away, and then if it's true, you execute the control statements, and then you loop back and check the test again. If at any point the test is a false or it fails, then we just resume execution at the end of the while loop after that last curly brace. Here's just a really simple little example where we have a number, it starts at 1, and then while that number is less than or equal to 200, we're going to execute the body, the controlled statements, where we multiply the number by 2 and then reassign it back into that variable. And so this will start at 1, and 1 is definitely less than 200, so we'll double it and we'll get to 2, and then we'll double it again and get to 4, and then 8, then 16, 32, 64, 128, and then 256, and that's when the test will fail. Here's another example of a while loop, and in this particular while loop we have a number that starts at 1. We check to see if it's less than a max or equal to a max, and then we execute some statements inside the body, then we increment that number by 1. And now when your while loop starts to look like this, you actually have 3 parts here: an initialization, a test, and an update. You're doing a for loop. And there's no reason to use a while loop if you're actually doing this. Just go back to the for loop syntax. It's a little cleaner, it's easier to read, and easier to tell that those three parts, they stay together and they belong together. So you can replace a for loop with a while loop, but it's not advisable in all situations. So let's do another example, and this is something that you may remember from math class. We're going to try to find the smallest divisor of a number. And so what we have here on the screen is just pseudocode. If you remember, pseudocode is something that's a little bit like code, a little structurally like code, but it reads in English. It's easy for you to read. And so we have an initial plan for our solution. We know what we want to do. We want to start at 2, and then while the current divisor value doesn't work, then we increase the divisor. So that's the description of our solution. But we might want to clarify some of this, because the first part and then the body inside the while loop, we could convert that to code pretty easily. But what does it mean when the current divisor value doesn't work? Well, let's think about our math class. The current for a divisor to work, it has to divide evenly into a number, right? And so another way of saying that is that the remainder of the number divided by the divisor is not 0. That means that the divisor did not go in cleanly. If ever that result is 0, that means it divided cleanly, and we've got a divisor that's valid. And so at this point, we can convert all of this into code. Start the divisor at 0. Well, that just is easy. We just assign an integer, or we declare an integer assigned to. And then to check the remainder, we use the modulus operator, number mod divisor, and then we check whether that's 0 or not. That lets us know whether it went in cleanly. And then we increment the divisor by 1. So yeah, great. Beware. One of the things that you can come across, especially when you're dealing with while loops, is that you can accidentally create an infinite loop. This could happen if you're checking the wrong direction. Maybe you meant to check whether a number is less than something or greater than something, but you can get into the body of a while loop and be updating the wrong direction and then never actually terminate. And that's what this code here does. Is we start at 1, and then if 1 is greater than 0, we increase by 1. Well, that's great, but it's never going to be less than 0 if we're increasing it by 1. All right, so another common pattern when we're doing while loops is that we're looking for a sentinel value. And a sentinel value is a special number, or it could be a string, or anything really, depending on the type of data that we're looking at, that signifies the very end of the input. Because we don't want to have an error and just crash, we may have this special reserve value that says, if you ever encounter this, stop, you've reached the end of valid stuff. And a common sentinel value is -1. And so you can see in our sample code here, we were trying to sum up a bunch of numbers. And there's this method called next value that's defined somewhere else. Someone wrote it, and it's going to give us the next value. And built into that method is this idea that it has a sentinel value. When there's no more values, it'll just return -1. And maybe that's fine for this situation. We're going to assume that maybe all values are positive. So if we ever reach that -1, that means that we've reached the end of our input. If you had a set of values for which -1 was a valid value, then you wouldn't want to use -1 as a sentinel value, because if you ever encountered it, you would wrongly tell the person consuming it that the input is over and they need to stop. At any rate, you can use things like this to end your processing. Okay, so another really useful concept is random numbers. However, computers and programs by nature are predictable and non-random. They're ordered, they're orderly. There's defined syntax, defined order that things go in. So it's actually really hard to have random numbers, but we want random numbers. So how can we take a system that isn't random, that's very clearly by definition non-random, and make it random? Well, that's where we have this idea called pseudo-randomness. And pseudo-randomness is it's just what it sounds like. It's like random, nearly random, similar to random. And so when you have pseudo-random numbers, these are numbers that, even though they're created from orderly, predictable algorithms, they are similar to numbers chosen at random. They can appear as numbers chosen at random. And Java has a special class or a special method on this math class, which we've been using for a while. If you just call math.random, it will give you a random number, but the distribution is between 0 and 1.0. So that means that the lowest number you'll get is 0, and you'll never quite get 1.0. It's always going to be less than 1.0, but it's going to be a random decimal value somewhere in there. And if you don't want your number to be in that range, then you can use a multiplication to change the range, like you want it to be between 1 and 10, or between 0 and 10, or whatever. You can create this mathematical expression that multiplies it, and then you convert it to an integer if you want a random integer. But that's kind of messy. And the people who created Java knew that that was kind of messy. And so they give you this convenience, or this series of convenience methods on a random class. And now these are object methods, so they're not static. You can't call random.nextInt because that would be a static method. In order to call nextInt to get the random number, a random integer number, you have to first do what we see at the top of the slide. You have to create a new object, instantiate a new object. And the syntax that we're familiar with for doing that is by using the constructor. So we have the type, random, the name, random, just with a lowercase r. And then we assign to that the result of invoking the constructor for the random class. And that's anytime you see the word new, that's someone is invoking a constructor. And then the constructor is just the name of the class typically. Well, it's always going to be the name of the class, capitalized. And then parentheses with optional parameters inside. In this case, we don't need to specify parameters when we're creating a random object. But once you have that random object, you can get integers. You can get integers specifying a maximum. Now that maximum, it's going to be max minus 1. And then if you call next double, it'll do the same thing that happens if you just call math.random. So maybe you don't, if you're just going to deal with doubles, you don't necessarily need to go through this. And you can also do like simulate coin flips by calling next boolean, where you'll get a random distributed value for true or false. Okay, so here's a quick little example where we're trying to guess a random number. So we have a result, integer result, and then we create a random object we call R, and then while the result is not equal to the number is the thing that it's defined outside of this code block here. It's the number we're trying to guess. So while our result is not equal to the number we're trying to guess, then we just try to get a random number between 1 and 10. R.nextInt, maximum of 10, and then we add 1 to it, so that'll give us 1 through 10. But if you looked ahead to the bottom of the slide, you see that this actually this isn't going to compile. And the problem is that we don't have an initial value. So int result is nothing, and we have to set result to something initially if we're going to be using it. And so what this is, the term that we use to refer to this is called priming a loop, and it's like priming a pump where we have to sort of kick off by setting an initial value to guarantee that we're going to actually go into the loop. So if we want to check the result against the number that we're trying to guess, then we need to set it to some initial dummy value. That's another term for this. And in this code example, we just use -1 again. That's a good dummy value if you know that, like, we're trying to guess a number between 1 and 10. We know it's never going to be -1, so let's just start at -1 just so we can get inside our loop and start guessing. Okay, so here's a common error, and it surfaces here as we're learning about the random class, and in particular the methods on it. but it's not specific to this class. It'll come up later on when we're dealing with other things. And if you look at this code, it looks like what we're trying to do here is we get a random number and then we want to tell the user whether it's even or odd. And if you look at the expression within the if statement, we are checking r.next mod 2 equals 0. So we're dividing it by 2 and getting the remainder. If that's 0, then yeah, by definition, that's even. So this code should be correct. Well, that part isn't the problem. The problem here is this and this. So we're calling next int twice. So when we call next int, every time you call that, it's going to get a new random number. So the value that we got, that we tested by dividing by 2, and then the value that we get when we print it out are not the same number. We might get lucky and they might be the same number, or like we might get lucky half the time and it will be an even number just by chance. But these are not related. So what we need to do is when we call that next int, we need to pull that number out. So int n equals r.nextInt. And then using that same number, we need to check the division, whether the remainder is 0. Great. And then make sure we're printing out to the user the same result. This comes up a lot. If you're calling a method and you're getting a new value every time, you need to make sure that you're like assigning it to a local variable and then reusing the specific value that was returned last time you called it, and not invoke the method each time you're trying to get the same value, because that's just not going to work. All right, so that brings us to the boolean type. This is also pronounced boolean. I guess I just got used to using the boolean pronunciation. I don't know that either one is correct. You're free to choose. At any rate, it was named after a logician, George Boole. Logic is kind of this math-related field, but it's also kind of related to philosophy. It's really interesting. And there's only two possibilities for a Boolean type. It's either true or false. And we've used these expressly at different points, but we've been using them very frequently without even realizing it, or I guess more specifically, without even calling it out. So yeah, we've been using it in for loops and if statements and in while loops. All of these underlined expressions evaluate to Boolean values. So the middle, the test statement in a for loop, the entire expression inside the parentheses for a an if statement, and then the entire expression inside the parentheses for a while loop. Those all evaluate to a Boolean before they're tested. And because of this, sometimes, especially if you're inexperienced, you can wind up writing code like this. So we have a Boolean value and we want to initialize it, or we want to set it to the result of whether or not some number x is less than some number y. And this if you look at this code, it's correct. Like if x is less than y, then we do set the Boolean to true, and if it's not, then we set it to false. That's perfectly correct. But there's no reason that the x less than y expression inside the if statement, that itself evaluates to a Boolean value that we test, and then we set the less variable to the same value. So it's logically identical to just combine this into one line where we assign the Boolean variable with the actual thing that we have in our if statement, or the test that's in our if statement. It's the exact same code. It's just that we've reduced it from 1, 2, 3, 4, 5, 6 lines to one line. And that brings us to a new type of operator. And these are operators that are used for Boolean values. And they're called logical operators. And there's 3 of them that we should talk about right now. There's and, or, and not. And is a double ampersand. Or is the double vertical pipe thing. And then not is just an exclamation before the statement. And you can see some examples and then their results on the right. Sometimes you'll hear these referred to as like conjunction, disjunction, and negation. Those are all kind of like formal sounding words that all just mean and, or, and not. So that brings us to the concept of truth tables. And truth tables are just a way of laying out all of your inputs and all of the results of a logical expression. And so here's a truth table for the logical expression of not some input. And so the input is represented here with P, and not operates on a boolean value, and the input can only have one of two values. It can be either true or false. And so that's what you see on the left-hand side. Our input of P is either true or false. And then the expression that we're trying to look at all the results of is not P. And if you look at the truth table, it's pretty simple. If the input is true, then not P is false. And if the input is false, then not P is true. So here's a more complicated one for and. And has two inputs, and those are represented in this table by P and Q. And you can see that there's four rows in this table, and that's because we wanted to come up with every single exhaustive input combination for all of these expressions. So these are both Boolean values. They can be either true or false, but we can have four different combinations if there are two inputs. There's true, 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 false, false, true, or false, false. And then on the right-hand side, we have our logical expression that we're checking against the inputs, P and Q. So for the and operator, the result is only going to be true if both your inputs are true. If the first one is true, the second one's false, then the result is false. Likewise, if the first is false and the second is true, the result is still false. And then obviously if both are false, then the result is false. So the other operator that we want to talk about is the logical or operator. And this one might not quite behave the way you would expect it to. And that's because English has a little bit of like ambiguity when we say or. An example is that like if you're talking about the weather, or the weatherman says tomorrow it's going to either rain or snow, and then tomorrow comes and it rains for a little bit and then it snows, you're not going to say the weatherman was a total liar. You're going to say he got it right because it rained and snowed, but in that case that still qualifies as like rain or snow. But if you were to say, like, tonight I'm either going to do my homework or I'm going to watch a movie, well, that statement seems to imply that you're not going to do both. You're going to pick one. But in programming, it's more of like the weather prediction model, where or will be true if one or the other or both of them are true. And so here's the truth table laying out. P or Q. So we have two inputs for or. There's the left-hand side and the right-hand side, and we have all the same like input combinations here. And you can see that it's true if the first is true, the second is true. It's true if the first is true, the second is false. It's also true if the first is false and the second is true. The only case where it's not true is if both inputs are false. And that's just how or works. So how do we use logical operators? Well, they can be useful if you have multiple tests, as we do on this slide here. So we're trying to check whether the number is greater than or equal to 1, or to see whether it is less than or equal to 10. So we're checking a range. We want to see if the number is between 1 and 10. And up until this point, if you weren't familiar with these logical operators, you might write something like this, where you have an if, and then a nested if, and then your statements within the nested if block. But now that we have logical operators, we can just take both those tests and combine them into one big test. And they're joined together with the double ampersand, which means and. So if the number is greater than or equal to 1 and the number is less than or equal to 10, then we'll go into our if block. And that's logically identical. Frustratingly, there are some things that just aren't allowed. If you're logically, these seem to make sense, especially if you're like thinking about mathematical statements. If x is 1 or 2 or 3. That seems to make sense. Like if you were to say that to someone, they would understand what you meant. But unfortunately, the Java compiler will not understand that. So what we have to do is combine the expressions with logical operators. So if x equals 1 or x equals 2 or x equals 3, we've really got to spell it out for Java to understand it. Another thing that might seem to make sense, you want to check whether a number is in a certain range. If you're to write like x, or this whole expression, 1 less than or equal to x less than or equal to 10, your classmates would understand that, your teachers would understand that, Java won't. You have to separate it, and that's why we have, like at the bottom here, we have 1, the first part, like whether 1 is greater than or equal to, or whether x is greater than or equal to 1, and x is less than or equal to 10. So keep that in mind, that this is a pretty frustrating limitation, but you just get used to it after a while and just learn to live with it. Okay, so let's revisit our operator precedence table, and we've already been through all of this, but what we really want to know is where our new operators fit in, and they're right here before assignment. So the logical AND has a higher precedence than OR, and will always get evaluated before ORs do. If you have a big combined expression where you're using multiple logical operators, just keep that in mind. Ands always get evaluated first, but they get evaluated after all of the things that we've seen so far, except for the assignment. So they're before assignment, but after all the other operators. Okay, so another really important concept to understand is short-circuited evaluation, and what this means is pretty. It's, I guess if we look at this table, it helps us to understand. So if I was to say to you, here are 2 candy bars, and maybe there was like a defect from the factory, and the labels didn't get printed right, and it's just like a white label on each candy bar, and I said, let me know if there's nuts in either one of those. And you open the first one, and it had nuts. You wouldn't have to open the second one to answer my question. You would just say, yeah, they have nuts. Because I'm asking you if there's nuts in either one. So that means or. And you can see that in this truth table. So P or Q is true when if you've encountered a true with the first input. It's always going to be true if the first input is true. And Java will actually short circuit that and do the same thing. It won't check the second input if the first one is true. It's only going to check the second input, for or at least, if the first statement is, or the first input is false. So if you check the first candy bar and there's no peanuts in it, then you're going to open the second one. And likewise, Java is going to do something similar. It's going to check the second value, or the second input, only if the first one is false. And sort of conversely, with the AND operator, Java is going to always check, like if I was to ask you the same sort of question, like here's 2 candy bars, I want to know if there's nuts in both of them. If you opened up the first one and there were no nuts, you could answer my question right away and say, nope, there's not nuts in both of them because there's not nuts in the first one. And Java can do the same thing. If the first input, like in this table, the first input is P, if the first input is false, it will immediately evaluate that expression to false. However, if the first input is true, just like if you open that first candy bar and there were nuts in it, you'd have to check the second one. So Java does the same thing. It will check the second input only if the first one is true. And that's for AND. Okay, so on to some helpful tips when you're dealing with boolean types. So here's like a pretty common thing that you see among early coders, and that's you have an if statement, and then your return, or within a method that needs to return. The return type of this method is boolean. Is boolean right here. And we're checking whether a number is even. So if n mod 2 equals 0, so we're dividing by 2 and checking the remainder, that is a valid test for whether or not something is even. you may be tempted to write this code: return true if this is true, and then return false otherwise. But the thing is, everything inside these parentheses evaluates to a Boolean value, and you're returning a Boolean value. Not only that, it evaluates to the same Boolean value that you're trying to return. So the better code here is just to return the test, because there's no reason to put in the return true and return false. It's kind of amateurish. Another thing, if you ever find yourself writing code where you're checking and you'd be surprised how frequently this happens. If you're checking whether something is equal to something, and then you return that something, well, just return the thing. You don't need to do all this. If this is exhaustive, if x can only be 1, 2, 3, or 4, just return x. Okay, so here's another common thing. You can, when you're writing code that has in a if test, it's taking as an input a Boolean value, and you're checking it against true. You don't need to do that. You can just equivalent code is just to use negative in this case, because that's the Boolean input that will be either true or false. You can think about it this way. Negative is going to be either true or false. And so what you're saying is, if true is true, then do this. And if false is true, then do this. Yeah, well, you don't need to do that. You can just say if true, if false. And that's what this second code block does. Okay, so there's also some variations on different loops. You don't see this one very often, but there is such a thing as a do while loop. It's very similar to a while loop, and you can see structurally there's a while, and there's a test, and then there's some controlled statements. But the difference here is that the controlled statements go first and the test goes last. And that's meant to represent that the statements actually get evaluated at least one time before you encounter the test. So when you see a do while loop, you know that the block inside is going to at least execute one time, and then if the test is true, it'll execute a second time, and then keep executing as long as the test is true. So here's our while loop flow. We've been over this one before. We check if it's true, we execute, and then go back to the test, and then if the test ever fails, then we just resume execution after the while loop. A do while loop is kind of a little bit weird, where we execute the control statement first, and then that's when we hit the actual test. Okay, another common thing, well, I guess this one isn't quite as common, but you'll see this from time to time, the special keyword break, B-R-E-A-K. And it's a statement in and of itself. You can see it here in this code block where it's just break semicolon. That is a statement. And it says to the executing code that when you reach this line, just exit the loop that you're currently in. So it can be a little confusing, so I would recommend using it sparingly, but it's also useful for getting out of a forever loop. So you can actually, this is perfectly valid code where you say while true, and that may seem insane because true is never going to be false, right? So this test would never fail. Well, that's actually true, that this is never going to fail, but there is a break statement here. And assuming that our get next number is going to eventually reach -1, which is our sentinel value. Remember earlier where we said sentinel, -1, would signify the end of input. So imagine that's the same situation here. So eventually we know we're going to hit -1 because we're going to reach the end of our input. So we do know this code will exit the loop, even though it looks funny at the first line. But it can be a little confusing, so I would not recommend using break that often. You can also see this weird for loop syntax. Technically, all three of the components of a for loop, the initialization, test, and update, are optional. And if you leave them all blank, it's the same as writing a while true loop. It looks really weird though. It looks like someone crying, so maybe don't do that. So you can see here we have a for loop and we have a blank initialization, blank test, and a blank update. So this is just going to go forever. This is logically identical to the previous slide where we had while true. Now we just have 4 and then 2 semicolons inside the parentheses. So yeah, I wouldn't recommend using this, but if you ever encounter it, that's what that means. It's just go forever. So check the block to see what the actual exit conditions of the loop are. All right, so now we are going to move on to some live, or to an actual example. Okay, so our coding project here is that we want to write a guessing game program, and the way that the program is going to work is that the program, or the computer, is going to pick a secret number, and that's going to be a number that ranges from 0 to 99, and we'll say that's inclusive, which means that includes the number 99. Then the user is going to make guesses over and over again, trying to get the secret number. If the user is ever correct, then the program should just tell them they won, how many guesses that they used, and then end. But to make it interesting, after each guess, we want the program to give a little bit of information. We want it to tell the user how many digits were correct in their guess. And I guess also we want to verify input. So we want to we want to protect against bad input. So guesses that are outside the range or aren't numbers, things like that. All right, so how should we go about doing this? Well, we have, I already have this number guesser .java file, and we can actually just start by writing some pseudocode for what we would want to do. And it seems to make sense if you're trying to make a number guessing game that the first thing you should do is just have the program think of a secret number. And then we have this while construct, but it's not exactly, again, it's pseudocode, so it's not exactly like an actual bit of code. What's our condition for continuing? While the user hasn't guessed correctly. So while the user has not guessed correctly, we want to keep going and keep doing what's inside this loop. And what do we do inside this loop? We want to ask the user for a guess, and then we probably want to report the guess. We want to report whether the guess was correct. So and we'll leave the fancy stuff for later. Let's just get our initial thing going. Let's start with iterative development, and our first version of this program is just going to be the simplest implementation, just this. So okay, well, we know that when we're making programs, we've got to start with, first of all, let's take my pseudocode, and I will use a multi-line comment so that it doesn't mess up. It'll be ignored by the compiler, and the code in here will still work. So we know we have to have all this classic boilerplate, this magical incantation, public class number guesser, or number guess, and this matches the file name, if you remember correctly. And then within here, we want to have a public static void main string bracket args. That's just something that has to be there that Java looks for to execute when it's running your program. Okay, so what do we want to do here? Well, let's just have a couple of we'll start with our while loop. We know we have a while loop, and then we do stuff before the while loop. What do we do before the while loop? Well, let's refer back to our pseudocode. We have to think of a number. Let's not try to actually get the secret number yet. If with our initial implementation, we're just trying to get off the ground, and we can pretend that this is a random number, but it's not going to be random. Let's just say it's int number equals, and then we'll always give the same one internally for testing purposes. We're going to make this random eventually. And maybe we'll make a note to ourselves to actually make this random. So this is our secret number that the user is trying to guess. All right, well, within our loop, what do we want to do? The condition for continuing is while the user hasn't guessed correctly. So we want to check the user's guess against the number. So we don't have a user guess yet, so let's create it. Int guess. Okay, so while the guess, and we know how to check whether something is equal, we just use equals equals. If we want to check whether it's not equal, then it's just the exclamation not equal. So while the guess is not the actual number, then we probably want to prompt for some input. We need to tell the user that we would like them to make a guess. So we'll just say your guess, question mark. And then we want to get some input. I'm actually going to skip that step for now. And then we want to remember, we want to report whether the guess is correct, but we also wanted to, in our initial implementation, when the user is correct, the programmer needs to report how many guesses were used. So inside this loop, we need to keep track of how many guesses the user has made so far. So let's create another variable outside the loop because we're going to report it at the end. We'll call it num guesses. This is the number of guesses, and we're going to start at 0 because the user has made 0 guesses. So yeah, in here we will say num guesses, and we want to increase it by 1. So we can say equals num guesses plus 1, or we could say plus equals 1. But the best way to do this, the clearest and simplest way to do this, is just to say plus plus. Num guesses plus plus. Increase it by 1 and store it back into that variable, num guesses. So at this point, what do we want to do? Let's refer back to our pseudocode. Within the while loop, we ask the user for a guess. We've done that. Now we want to report whether the guess is correct. So let's tell the user what's happened, and we'll just print out a message. System.out.println. We know at this point whether or not the guess was correct because that was a condition for being inside the loop in the first place. So we will say incorrect. And then what's our last step? We know that after we exit this while loop, the user must have had a correct answer, or else this test would never failed. So let's put that in here. We'll say correct, and then we want to tell them how many tries you got it in, and how many tries was it? It's num guesses tries. That's how many times the user has guessed. GUESSES, and then space tries. All right, so let's save this. Let's attempt to compile it. We may have made some errors, or I may have made some errors. Java C num guesses.java. Oh, it looks like I have made an error here, and the error is actually pretty important. It says that this variable guess might not have been initialized, and this is touching back on our priming the loop concept that we were talking about earlier. We can't enter this loop if guess is not initialized. And so at this point, we should kind of revisit our pseudocode and kind of think about what we need to do. In order to get into the loop, we have to get a guess before we even start. So looking at our pseudocode, let's think about this for a second. We do want to think of a number. That part is correct. And then we probably want to ask for a guess. And we already have that step here. We'll say ask the user for a first guess. And then while while the user hasn't guessed correctly, that's good. Then we ask the user, well, we probably actually want to reverse the order here. We want to report whether the guess is correct and then ask the user for another input because we have a guess. We don't want to ask them right away and wipe out the initial guess. All right. And then at the end, I kind of left this off the initial one. We want to report the number of guesses used. Okay, so how would this actually affect our code? Well, mostly this is correct here. We have num guesses. That's good. Only what we want to do here is add this extra step. So we're thinking of a number which isn't quite random yet. We want to ask the user for the first guess. So we'll say num guess equals. And at this point, I'm going to sort of introduce something that I haven't talked about at all in my slides, and that's a special way of getting input from a console, from a command line. We're not going to be, eventually we're not going to be using the command line at all. We're going to be getting our inputs from other sources. But in order just to get off the ground, to get this working, we have to start using this thing called a scanner, and I'm going to just sort of gloss it over. So the scanner is going to be like this. So it's an object, and then we have to create a new scanner because it's an object. And then we use this constructor syntax. So there's the new keyword, the scanner name, and parentheses, and it takes as a parameter, or what if we want the scanner to be reading the terminal or what the user is typing into the command line, then we want to call it system.in. All right, system.in. And then when we get a guess, we're going to say to our scanner object, which is named console, next int, and that's going to give us the next integer that the user inputs. Okay, so what we want to do now is implement this step right here. We want to get another guess within the loop, although we've kind of moved things around. So yeah, what we want to do is first tell the user whether their answer is correct or not. We know that if we've entered this loop at all, that their answer is incorrect. It has to be incorrect. That's a condition of getting into the loop. And so then we tell them that their guess is incorrect, and then we want to increase the number of guesses. So those things should happen here. And we probably want to prompt the user for another guess, which we already have, your guess, and then we get the input. And the input is just going to be the same line that we just did, only we don't have to redeclare guess as a variable. It's been declared outside the loop, but we do need to reassign to it a new integer. And remember, even though this line looks the same, console.nextInt, console.nextInt, each time this is invoked, it's going to get a different number, unless the user is entering the same guess over and over. But that's a user error. That's not your error. Okay, and then I think this last line is correct. So let's save this and compile it and see what happens. And what's going to happen here is it's going to say that it can't find the scanner symbol. And the reason why is that I have not imported scanner. So remember, we have these import statements, java.util.scanner. That's the package for the scanner object is in java.util. All right, so we have compiled. Let's try running it. And nothing happens. Why does nothing happen? Well, let's refer back to our program. we wouldn't expect something to happen because we didn't actually prompt the user for an input initially. It's actually waiting for me to guess here. Let's actually see what happens if I enter a guess of 1, enter. Incorrect, your guess. 2, incorrect, your guess. 42. I got it right. How did I do it? Well, I knew the answer. But I found a bug in my program. I need to prompt the user for input. So the program is waiting for input, but I haven't told the user that they should be entering input. And I can do this right before, I want to do it before next int. If I do it after next int, it's going to print out the line. I can actually show that to you after this line here. This is going to look a little funny. So compile and then run. 1. Okay, so it says your guess. That's because I put the prompt after I tried to read the input. So it's saying, what's your guess? Incorrect. Your guess? So that's not quite what I had in mind. Let's put it before. And then Control C to exit this. And we will say compile and run. What's your guess? My guess is 33. Incorrect. What's your guess? Well, my guess is 100. Now, 100 is an invalid number for this range. It's supposed to be 0 through 99, but I'm not checking those things right now. I can do -4. It's incorrect. What's my guess? 42. Correct. You got it in 3 tries. Okay, so at this point, we want to implement the part that I've kind of glossed over right here. Actually make this random. And this is something that we did go over in the slides, how to use actual random numbers. And so we can do this. So what we want to do is create a random number generator. And we do this by using the random class, and we'll call it rand new random. So this is an object named rand. The class is random, and we're using the constructor syntax here where we say new random. And now we want to get the next random number, and we do that by doing rand.next int, and we give it a range 100. And so what that's going to do, if you remember, that's going to guess from 0 to 100, but it's not going to include 100. And that's what we originally laid out to do, is to say we're only going to do numbers from 0 to 99. And then where in here, yeah, everything else in our code should work. So let's try running this. But, oh, okay. Here's actually an important thing we've left off here. And so what we need to do at this point is just import the random class. So it's going to be in the same package. And our imports should be in alphabetical order, which I've done here. R comes before S. Let's try compiling again. It compiles. Let's try running again. And what's our guess? Well, I'm going to guess 42. No, 42 is no longer correct. Well, what is it? Is it 75? I don't know. Is it 9? I could do this for a while until I got it, but that might be a little boring. It could take like up to 100 guesses. So I'm just going to Control C and end my program, because I'm not giving myself, or I'm not doing the important step of right here, after each wrong guess, the user or the program reports how many digits were correct. So let's try to figure that one out. Well, revisiting our pseudocode. So while the user hasn't guessed correctly, report whether the guess is correct. So let's write the pseudocode for inside here, whether or not or how many digits the user has gotten correctly. So we report whether the guess is correct, and then we ask the user for another guess. But but between those two things, let's do the work of figuring out how many digits matched. So we'll say matches, which is going to be short for digit matches. We'll say it's 0. And this is pseudocode, so we don't need semicolons. We'll use if. And what's our condition here for checking the first digit? If the first digit matches the secret number, but we want to check actually against we want to check the first digit of our if the guess first digit matches the secret number's first digit, or if it matches the second digit, then we want to increase matches by 1. And we want to kind of do something similar for the second one. If the guess's second digit matches the secret number first or second digit, then we increase the matches by 1. Now that's almost correct, but I'm kind of forgetting something here. So the problem here, if you think about this, is that consider the case where the user has guessed 33. So our guess is 33, but the secret number is 13. So if the guess first digit matches the secret number's first or second digit, so it matches the second one, so we're going to increase the match by 1. And the guess's second digit, which is also 3, matches the first digit or the second digit and matches the second one, we're going to increase the matches by 1. So in that case, we're going to tell the user that they have 2 digits correct, but that's not true. They only have 1 digit correct. So what we want to do is add an extra step, an extra condition on this second check. We want to make sure that the digit is unique. So we'll say we will say the second digit is different from the first digit, and the guess's second digit matches the secret number from the first or second digit. So yeah, that should work. Let's implement this. So let's start by this is a lot of logic here to just dump into the middle of our loop here. So let's create a method. Anytime you see like a lot of code going into one spot, it's a good idea, and we'll go over this concept later, to create a method for containing that. So we'll call this, it has to be static because we're referencing it from another static method. So, but we're going to return the number of digits that matches, and that's going to be an integer. And we will call this num correct digits, and we want to pass in some parameters. And what parameters do we want to pass in? Well, we want to pass in the guess, and we want to pass in the secret, because that's where we're going to be comparing those two things. So if well, actually, for the first thing we want to have in here is the number of correct digits that are the number of matches. The user could have potentially 1 or 2 correct ones, or well, 0, 1, or 2. So we will say int matches equals 0, and then if we'll say in here we'll check the first digit, and we'll get to that in a minute. For now, I'm just going to say first digit, and then I'm going to put an empty line in there, and then we'll call this second digit. And then at the end, we are going to return matches, right? And in here, if it matches, or if the first digit is indeed correct, then we will increase matches by 1, and we know how to do that. It's just plus plus. And similarly, we'll do the same thing for the second if. But now comes the sort of confusing, difficult to think about problem. Let's start with the first digit. How do we know whether the first digit matches the first or second digit of the number? Well, we can rely on the way math works in programming. So first thing we can do is just divide both numbers by 10. We know that in integer division, if you divide 25 by 10, you're not going to get 2.5, you're going to get 2. It discards everything after the decimal. And so if we want to compare that first leftmost digit, we can just divide both of them by 10. So let's start by that, or start by doing that check. Guess divided by 10 equals secret divided by 10. So that's correct. But now we want to check the second digit of the secret. And how do we get the second digit? The second digit is actually what's left over when we divide by 10. We know that if we divide any number by 10, or then there's going to be some remainder left over. And the way that we get remainders in Java is by using that special modulus. So guess divided by 10, because we're still checking the first digit, but we're checking it against the secret mod 10. So yeah, this works, but if you look here, we're kind of getting a little bit repetitive, and this violates the don't repeat yourself principle. So I'm going to create some variables up here to help us read our code better. And the first thing I'm going to do is separate the digits. So we'll call this guess first digit, and then we'll just say that's guess divided by 10. And then we're going to have a guess second digit, and that's going to be just guess mod 10. And we're going to do something very similar for the secret, only we're going to call it secret first digit and secret second digit, and in both cases we're using the secret number instead of the guess number. And you can see that by just doing a small naming change here, by creating some extra variables, it's going to make this test a little bit easier to read. So we're going to say if the guess first digit, and now it's becoming very clear what I'm actually checking here. If the guess first digit is the same as the secret first digit, or that's what the or is, that's what the double pipes are. If the guess first digit is equal to secret second digit, that's the secret mod 10. Okay, so if guess first digit is equal to secret first digit, okay, great, that's fantastic. And so now we want to have our two checks in here. And what are our two checks? We want to check whether the guess second digit is different from the first digit and some other stuff. So let's do the and first, or let's do the first part of that first. How do we check whether the first digit of our guess is different from our second digit of our guess? Well, it's pretty simple. Let's just say if the guess first digit is not equal to the guess second digit. Great. So that check right there, when we're checking whether the first one is the same as the second one, that is going to give us the correct answer, or the correct implementation for this. Okay, so is the second digit, the guess second digit matches the secret number, first digit or second digit? All right, well, we can do that. It's going to be mostly similar to what we have up here. And now things are going to get a little confusing here because I have ands and ors. So let's do and. What I'm going to do here is write all that out. So secret second, guess second digit equals secret first digit, or the guess second digit is the same as the secret second digit. And now my test is starting to get very long and kind of a little bit difficult to read. So at this point, let's clean this up a little bit because there's actually a bug in here. First of all, I'm going to put a line break right after the and then I'm going to change my indentation to be, let's see, when you do this, when you put a line break in here, you, instead of indenting it to the level of the body, you give it an extra level of indentation. So that makes it a little bit clearer that there's two tests here and they're joined together with an and. And that raises an important concept. If you remember our operator precedence, the and is going to get evaluated first. And so it's going to check this entire statement and then it's going to check the second statement. And that's not what I actually intended. And so I'm going to use parentheses there. So parentheses, just like in your math class, will cause, they have a higher precedence. So now this will get evaluated first. Okay, so is this correct? Well, let's give it a shot. Compile all that code and no errors. All right, what's my guess? My guess is going to be 80. Well, 81. Incorrect. Your guess. Oh, I'm not using my code. So I wrote this method and I didn't actually refer to it. So yeah. In here, incorrect, I want to say how many matches. Incorrect, number of digits matching. And then I'm going to invoke this method right here. Num correct digits. And I can do this method call right in line here because we know that it returns an integer. So this will be evaluated and then it will be appended onto the string. And what are the parameters? Well, I need to pass in the guess and I need to pass in the secret. What's the secret? The secret is this number. So what's my guess? 81 is my guess. Incorrect. The number of digits matching is 0. So let's try 23. Oh, okay. So 23, I got one of the digits correct. Let's try 24. Well, actually, I've already done 23. Let's do 45. Okay, so I know that between 23 and 45, I have both digits. So let's try 24. Only one matches, so let's try 35. Well, actually, I don't want to do that. I want to do 25. Correct. You got it in 4 tries. Hey, that's awesome. Okay, so we have that, but there's another issue that I kind of wanted to go over here. We need to verify our input. The user might, let's actually just try running my code and see what happens. So if I try to guess like a huge number, Incorrect. The number of digits matching is 1. This is not ideal. The user could go on like this forever. We need to make sure that they're guessing numbers that are within the certain range. And if they give us a number that's not in the correct range, we need to tell them that it's not in the correct range. So let's create a method for doing that. And we will call this method, it has to be static, remember. We're going to call this method getAGuess. And you can see I left off the return value because I wasn't sure what it was. Okay, getting a guess. Well, getting a guess is going to be an integer. The numbers should always be integers. Okay, and do we need to pass any parameters in to get a guess? No, we actually don't. Not necessarily, at least. Actually, now that I think about it, we do need to pass something in because we're going to be using this console object. So yeah, we need to pass in a scanner, and we'll call it console within our method. Okay, so what do we do when we get a guess? Well, we're doing it up here over and over again. It's just this. That line right there, that's all we have to do to get a guess. So what do we want to do in our getGuess method? Well, we want to continually prompt the user for numbers until they finally give us one that's within the correct range. So what do we do? Well, we know that's going to be a while loop. Right now we have this int guess equals console.nextInt. That's a good place to start, and a good place to end is to return the guess. But we want to have a check in here while the guess is incorrect, or not while the guess is incorrect, while the guess is in an incorrect range. So what's an incorrect range? Well, we know that it's less than 0. Well, the guess is less than 0. It's also greater than 99 because we've said the next int can be up to 100, and that means that's not including 100. While the guess is less than 100, or the guess is greater than 99. Whoops. While the guess is less than 0, or the guess is greater than 99, we're just going to keep getting guesses. Although we do want to say to the user what's wrong. Or not what's wrong necessarily, but we do want to let them know that they need to give us a new number, or else the console's just going to sit there prompting, and there's no actual indication to the user that they've given a bad guess. We'll say number must be between 0 and 99. Your guess? Yeah. This seems good, although the first thing that we do in here is that we get a guess from the user. So maybe we want to have this prompt happen before we tell them to start giving us the number, else we'll have that confusing situation that I created for myself earlier. All right, so now everywhere where I'm getting this console.nextInt, let's do getGuess. Compile and run. Okay. Your guess number must be between 0 and 99. Your guess? Oh, well, it looks like I've left in these your guess statements, which I no longer need because the prompting happens within the getGuess method. Control C, Java compile, and Java run. Number must be between 0 and 99. What is your guess? I'm going to say a bunch. Uh-oh, what happened? Input, yeah. Mismatch exception for input string. Okay. Okay, whoops. Okay, so let's try this out. We will do a compile and a run. And what's my guess? Well, my guess, I'm going to say 999. Okay, so the number must be between 0 and 99. What's my guess? We'll say -8. Number must be between 0 and 99. What's your guess? We'll say 42. Incorrect. So the number of digits matching. So maybe I don't want to say the number must be between 0 and 99 every time. Maybe I just want to say it in here. Let's make that optimization. This is just sort of a more friendly. We don't want to tell the user that they're, or almost accuse them of making a mistake. What's your guess? 666. Oh, well, that's out of range, so let's give it a valid guess. 42. Incorrect. Okay, so now it's prompting me. I didn't make an obvious mistake, so it's just giving me the simple your guess. Awesome, so we'll say 56. Number of digits matching. Well, okay. We know that 42 and 56. Let's try 46. Ooh, so the number, cool, awesome. I finally hit this state where both digits are matching. How can that be? Well, I must have them in the reverse order. Cool. Yeah, I'd say this is pretty good. I think this is perfectly fine. Let's call it good for now. That concludes our session, and thanks for tuning in, and stay tuned for the next video.